So today we discuss coherent and incoherent addition of waves. So here we discuss that what is interference. So interference means that the interfere of two waves, means the superposition principle, means actually the addition of two waves. So addition means there the displacement of waves are added, and we get added means vectorically added. Obviously the vectors from the displacement are produced by the each wave, and if I added these two we get a superposition. So this is called interference. Interference means interfere two waves. So here we discuss coherent and addition of waves. Okay. So mainly we discuss the interference. Mainly interference. Interference means interfere of two waves or more than 2, 3, 4 waves. Okay, interference means if I added this displacement of two waves. Suppose there needed some two needles. This needle 1 and here is another needle, and this is a calm water or pool or lake. Okay, and if a needle are moving upward and down, okay, up and down motion in identical fashion, the water in water, so they produce a wave. Okay, so now wave is look like this. Okay, so wave. Okay, okay. So and here the two sources is S1 and S2, and there are some distance here at some point P. So that distance from P to S1, this distance. P to S1 or called S1P, and if I say that is another distance from P to S2 and S2P, these two distance. Okay, if these two distance is the same, so these two source is S1P equal to S2P. These two distance is the same. So these two source means these source is S1 and S2. These two needle source, there's 2 point. This source is called coherent source. So what is coherent source? So definition: coherent source. Okay, at particular point, at particular point. Okay, the phase difference between the phase difference. Phase means angle. Okay, phase difference between the source. Okay, the sources and the displacement between the displacement produced by the each wave by the each wave does not change with time. Does not change with time. So these happen when the two sources are coherent. So means this displacement, these two displacement be same for coherent source. Okay, these are coherent sources. And here we discuss the interference. The interference means if I added vectorically added these two waves. So S1 produce a wave called a Y1 and S2 produce a wave Y2, and another key point, okay, phase difference between the displacement each wave with, okay, there is no phase difference, they are in phase. Okay, so means, so Y1 produced by S1 point, so that is equal to A cos omega t, and suppose y2, so there is no phase difference, so that is equal to A cos omega t, both be the same. So y1 here, this wave y1, suppose wave is now look like this, is a producer wave, and these are y2, okay, and both be the in phase, so there is no phase difference between these, okay. These are y1 produced in S1 and y2 produced by S2. So if I interfere means they are the vectorically added, okay, interference means they are vectorically added. So their interference pattern, interference pattern. So actually, we put superposition of two waves. Actually, get superposition of two waves or more than two waves means vectorically added. Means vectorically added or algebraically added. Okay. So vector sum, what is the resultant vector sum? That is equal to y, that is equal to y1 plus y2, and y1 equal to a cos omega t, a cos omega t, and y2 that is also a cos omega t. If I added these two, we get twice a cos omega t, that is a y. Okay, so that's the concept. Interfere, when two waves interfere, okay, they sometimes these are they are matching here, so the amplitude must be sometime added or sometime amplitude be the zero. Okay, so here there is the intensity, so amplitude here is a called a intensity here. These are the intensity of the wave. When two waves are superimposed, sometimes the wave, actually amplitude of the wave sometimes very high or sometimes very low. Keep in mind, okay, when the interference, sometimes amplitude may be high, sometimes amplitude may be low. So that amplitude is actually proportional to the intensity. So this amplitude is proportional to intensity. The intensity proportional to amplitude, square of the amplitude, obviously square of the amplitude of resultant wave, that's the resultant wave. Okay, so here that is a twice a, so the intensity I, suppose that is 4, 2 square 4, that is I naught. Okay, so what is I naught? I naught represents the intensity produced by the each of individual source. So what is I naught? So what is I naught? I naught is the intensity produced by each of individual source, each of visual source. Okay, that's important. That's the intensity. So that is I0. Okay, that is proportional to a square, amplitude square. So here is another important factor, that the amplitude. Okay, that's the perpendicular bisector. Okay, that's the perpendicular bisector. So the intensity for I naught, the two sources are with the interfere. Okay, so what is interference? The definition of interference. So interference means interference of light is the phenomena of multiple light wave interfering with the one another, under some circumstances, under some tenses, causing the combining amplitude, the combining amplitude, combining is important, amplitude is the important, combining amplitude of the waves, to either increase or decrease, to either increase or decrease. Okay, so amplitude either increase or decrease, okay, to interfere. So when amplitude is increased, is called constructive interference. So constructive interference means the intensity is very high. When amplitude is decreased, this is called destructive interference, and destructive interference means the intensity is zero. So there are two types of interference. So interference, one is constructive, other is destructive. Constructive is destructive. Okay. So what is constructive interference? Means the intensity is very high. Intensity very high. I also call the maximum. And here destructive intensity is minimum or very low. Very low. Almost you can say that is a zero. Intensity with a zero. Mainly intensity. The amplitude with a zero. So same condition here. The two sources here, the S1, S2, the two pin or two needle up and down in the calm water. Same condition here. For constructive interference, same condition. The two needle up and down. Suppose here. Okay. Suppose S1, that needle. Suppose this needle and another needle here. Suppose this here. These are the S2, here the 2 point, S1 and S2 point, and we get a wave here and choose an arbitrary point here, sub point is Q. Here similarly like that, we choose the arbitrary point P here, and this S1P and S2P be the equal. Okay, there's a coherent source. So here the displacement now look like this. And another look like this. Okay, so now the two waves are look like waves. Okay, and here is another. Okay, so now this diagram is now look like this. So counting that S1Q, so that S1Q displacement, that is equal to here, that is 1, 2 and 3. The 3 lambda, 3 wavelength here, and here S2Q in this distance, S2Q, and these are the S1Q, and that's the S2Q. So that's actually a path here. So S1Q path and S2Q path. So S2Q counting here the full cycle 1, 2, 3, 4, 5 and 6. That's a 6 lambda. So now the path difference here, the path difference. So path difference. So that is equal to S2Q minus S1Q, that is equal to 6 minus 3, that is a 3 lambda, and 1 lambda, there is a 2 pi, the phase is 2 pi, there is 3 lambda, that is 6 pi. So the path difference is 3 lambda and phase difference is 6 pi. So the path difference is 3 lambda and phase means angle difference, that is 6 pi. That's also an even number. Okay, there is a 6 pi is the even number. So now, so that two waves. So y1 produced by s1 and y1 here produced y2. The two waves are, so y1, if I say the y1, say that is a cos omega t, and y2 that is a cos. Okay, now there omega t minus, there is a 6 pi here, that is minus 6 pi. Okay, and the omega t minus 6 pi means also we get similar condition here. Okay, get a cos omega t. So that means mathematically that's the S1Q and S2Q, where these two waves are in phase. So okay, so they are in phase, so that path difference 3 lambda, phase difference 6 pi. Two waves are in phase, so means the intensity is 4 I naught. So the two waves are in phase. Actually, the no phase difference. So means the resultant intensity I equal to 4 times of I naught. Each wave is get by I naught. Okay, that's the 4 times I naught. So we get constructive interference. So we get constructive interference. So we get maximum intensity means constructive interference. Okay, because they were these two waves y1 and y2 are in phase, so that's why the intensity is high. Intensity, I mean intensity maximum. So that's why these two are constructive interference. And now these two sources are coherent source. Now we discuss destructive interference. And now destructive interference is now look like this. Now the two destructive interference, the two sources, the two needle here, that's the S1, and here the another, that's S2. And you choose any arbitrary point. Suppose now you choose R point here, and the path is, okay, source point these two, so that is S1, obviously S1R and S2R. Okay, so now the wave is look like this. So that wave, that is y1, that's the y2. So the y1 wave, okay, now the path from S1 to R, this path S1 to R, this path is from y1 wave. To calculate the wavelength, so that is 1, 2, 3, 4 and 4.5, that is 4.5 lambda, that's the path, and S2R, this length S2R is 1, 2 and 3, that's the 3 lambda. So the path difference between S2R and minus S1R, so the path difference, so the path difference is S2R minus S1R, that is equal to S of 3 lambda minus 4.5, get minus 1.5 lambda, that's the path difference. So what is the phase difference? So phase difference is 1 lambda means 2 pi, and 0.5 lambda, that is another 1 pi, of 2 pi plus 1, 3 pi. So minus 3 pi. Okay, so that's the phase difference. Now the wave y1, that is, if I say that is a cos omega t, so the y2, that is a cos omega t minus, and this minus the plus, get 3 pi. So that is equal to, that's very important, the difference is, if I calculate, we get minus a cos omega t. There is a minus. So obviously these two waves are y1 and y2 are out of phase, not in phase here. Okay, so these two waves are out of phase. So y1 and y2, so y1 and y2 are out of phase. Out of phase. So if there is out of phase, then now the result and displacement, actually that is difference of it. So y1 and y2 are out of phase. Okay, so the out of phase means they create a destructive interference. So out of phase is create destructive interference. So the resultant intensity, suppose that is equal to 0, so intensity here is 0. So the max intensity with 0. Now the displacement is the out of phase, so the total displacement will cancel out and give the 0 intensity is the destructive interference. Okay, so there is a 0 intensity. Let's create 0 intensity. And for constructive interference, they create a maximum intensity. Okay, create a interference phase, get maximum intensity. Get a maximum intensity. Okay, and for constructive interference, and for destructive interference we get 0 intensity. Okay, for to summarize these two intensity, constructive and destructive here, and next page, and if difference, path difference, S1p and S2p, if there is a n lambda, if n is a number, okay, suppose n equal to 0, 1, 2, 3, so on, the two sources are coherent, or actually they are in phase, the two sources are coherent, the two sources are coherent. Okay, means in phase, the wave are in, the two waves are in phase. So the path difference, the path difference, and create constructive interference, and create constructive interference. Now if another condition, if S1p difference, path difference S2p, that is equal to n plus 1 by 2 lambda, means this, that is we get 1.5, n plus 1.5 lambda. Okay, 1.5. So now that is n equal to 0, and that is 1, 2, 3 and so on, 1, 2, 3, so on. So 1 plus 1 by 2, that is 1.5, and 2 plus 1 by 2, that is 2.5. There's a decimal, obviously there is no decimal here. So in case of decimal, they create a destructive interference, the resultant intensity is 0. So here create destructive interference, and the resultant intensity that is 0. Okay, therefore there is a minimum. If you take a arbitrary point, suppose if I summarize these two, if we know that point, we know that point R here, we know that point R here, and create that. And if I for destructive, for constructive, we know the Q point here. And suppose in these two, you know, this is not a point actually the basic concept here and jump and divide these two parts. Sometimes they are in phase, sometimes they are in out of phase. So in phase they create a constructive interference. If two waves means a y1 and y2 are out of phase, they create a destructive interference. Okay, so now if we choose any arbitrary point, we choose arbitrary point, point. So arbitrary point means any value. Okay, so suppose S1 create here y1, that is a cos omega t, some wave, and S2 create y2 and a cos omega t. Suppose there is a phi, so phase angle, suppose is a phi, omega t plus phi, the phase angle. So the phase difference, so phi is the phase difference of two waves, of two waves. So the resultant displacement, that is y equal to y1 plus y2. Interference means they are algebraically added or vectorically added, obviously. So that is a cos omega t plus a cos omega t plus phi. So that is equal to we added these two, a common, so cos omega t plus cos omega t plus phi, and you know the trigonometry, some ratio formula apply, trigonometric formula apply here. So cos c plus cos d, so we get, okay, that is 2 cos c plus d by 2 and cos c minus d by 2, that is twice a cos omega t plus phi minus omega t by 2, and another cos omega t plus phi sorry, there is a plus, if it is a minus then a plus omega t by 2, that is twice a cos, these two cancel here, that is phi by 2, and here cos twice omega t plus omega t, twice omega t plus phi by 2. And if I separate these two here, that is twice a cos phi by 2 and cos twice omega t by 2 plus phi by 2, and we get twice a cos phi by 2, and here it is cos, these to cancel, omega t plus phi by 2, that is the resultant waves. Okay, these are the displacement. Okay, so now in a wave, so there is an these part represent the amplitude or the intensity here, and these are the normal wave. So these represent amplitude, means they actually represent the intensity here, and you know the intensity that is equal to I, that is fourth of I naught, and here the another factor, the square of this square of the amplitude, that this factor here. So now this factor is a cos phi by 2 square. These are the intensity. These are represent intensity. Okay. So here, so the phi. So what is the value of phi? The phi is the phase difference. Okay. So that is for constructive, for 0 plus minus 2 pi, with an even number, plus minus 4 pi. So these are given for constructive interference. Given constructive interference for phase, and if phi equal to suppose plus minus pi odd number, plus minus 3 pi, plus minus 5 pi, and so on, we get destructive interference. Yeah, destructive. So destructive interference means intensity minimum, which is called 0 here. Here for constructive interference, so the phi phase angle with the here that even number, so you get maximum intensity, max intensity. Okay. So here is the summary. If the two waves are coherent, when the two wave, okay, the same as coherent, okay. The needle up and down regularly. The needle up and down regularly. Okay. So here we get a phase difference. Okay. So we get a stable interference. We get phase difference and get stable interference. Okay, and maximum minima will not change. So maximum means maximum intensity and minimum intensity not change. So max and minimum intensity is not change. Okay, clear? But here the some source are not coherent. Some source, actually these are not summary, these are some extra point, or you can say the summary. Okay, not very important here. Some are not coherent, and so at that the maximum and minima are varying. That time maximum minima means max intensity, max and minimum intensity is varying. Actually not continuous, they are varying. So now if they are varying, so now we calculate average intensity. So here the summary first part, the source are coherent means same as coherent. So means maximum are not changed. Okay, intensity are same gap are same maintaining. But here when they are not coherent source, so maximum minima are intensity, maximum minima intensity mainly that is varying. So means the pin up and down are not in regularly interval. Okay, sometimes S1 is very fast and S2 is slow, or vice versa. So now that time we calculate average intensity. At that time we calculate average intensity. Average intensity. So the average intensity means I, this is the average sign, that is equal to 4I naught, that's the average, and cos square pi by 2. This sign, okay, these two less than and greater than inside between these two, these represent the average. So if I calculate that average of cos square phi by 2, so these are the function. Suppose if I say that is a fx, so the average means that is a fx average, that is equal to full. So now you calculate the average means that is equal to from 0 to t cos square pi by 2 dt by total time period. Okay, that is 1 by t, that's the average. And if you calculate integrate these, so get similar concept, that is 1 by twice t 0 to t 2 cos square phi by 2, and suppose dt, and actually that phi and time they are dependent. Okay, suppose so that is 1 by twice t, so 0 to t 1 minus 2 cos square theta, that is 1 minus sine 2 phi by 2 So here that is dt, and if I 1 by 2t, so 0 to t dt minus 0 to t sine phi, suppose called d phi. Okay, suppose it's called d phi. Change the limit, that is d phi, and you can change the limit d phi. Okay, limit that change, that is d phi. D phi, suppose 1 by 2t, the integration t is a small t, and put upper limit minus 12 limit with a 0, and that is a sine means a cos. So that is minus cos, that is a minus minus a plus, so cos theta 0 to t. So now 1 by 2t times t get 1 by 2 here plus cos t minus cos 0. So here that is 1 by 2 cos t means cos 2 pi minus cos 0 with the 1, and here 1 by 2 plus cos 2 pi, cos 2 pi also 1 minus 1, and that term we get 0, that is final answer is 1 by 2. So that's the function we get 1 by 2, and that's the average intensity, the average sine, that is equal to 4 I naught, okay, times 1 by 2, and 4 cancel, get 2. So that is intensity 2 I naught. Okay, that's the average intensity equal to 2 I naught. Here we discuss the incoherent source. Okay, for because the max and minima are varying here. Okay, that's why these are the incoherent source. So the definition of incoherent source is very important for board exam. You get 1 or 2 marks question. So write down here the incoherent source. Incoherent source. Yes. Now when the path difference between difference uh, between two vibrating source, so difference between two vibrating source change rapidly with time, change rapidly with time. So phase difference here, the change rapidly with time. So the two sources are called incoherent. So the two sources, the two sources are called incoherent source. Clear? What is coherent source and what is incoherent source? So today's class little bit longer, so I end here. If you have any doubt, please ask in comment section. I will try to give the answer. So next class we discuss interference of light wave and Young's experiment. That's very important. Okay. So today I end class here. If you have any doubt, okay, ask in comment section. So thank you.